back again.
Hello, hello. I hope you're sparkly today.
Because
And
Mr. Bobby is.
make sure your shoes match your jacket.
Today we're looking at representing categorical variables with tables. Specifically, the tables we're looking at are frequency tables and relative frequency tables. And so we're just going to dive right in today. There's a couple of different realms of statistical graphs and information. One of them is descriptive statistics, which is a branch of statistics that includes methods for organizing and summarizing data, sort of a visual representation of what's happening so that the population or the readers of whatever information have a quick and easy way of understanding what's going on. And then you also have inferential statistics, and inferential statistics is when you're wanting to make a decision about something based on statistics. So we have a couple of different things there, and we're actually going to do both in this class, but we're going to start with descriptive statistics. So just a visual understanding of kind of what's going on here, okay?
Statistics is what you'll see all the time in newspapers and story and articles. Inferential statistics is what scientists and engineers do to make a decision.
Exactly right, exactly right. So we're going to just quick essential knowledge here. We need to understand that a frequency table gives a number of cases falling into a certain category. You actually probably talked about frequency tables in like 7th grade, okay? And then we also can talk about relative frequency tables, which is when we switch from how many to what proportion or what percent fall into that category. So just kind of keeping that in mind. Another thing that's going to happen, and we're going to say different words over and over again. So we're going to say like percentages, relative frequencies. We might say rates. We might say, you know, any of those things. And really, we're talking about the same thing, same exact thing. Yeah, proportions. And then counts and relative frequencies of categorical data reveal information that can be used to justify claims. Now, I want you to understand that, like, when we represent it in a table of a graph, we're not yet inferring anything about it. So that would be a transition from one to the other, okay? So, oh, we are in the way on my screen for me to be able to read this. Let me move us. I just moved us. I'm gonna have to move this again. There's too much on this screen. So graphical representations and statistics allow us to identify and represent key features of data. An appropriate graphical or tabular display of data can be an effective way to summarize and communicate information. When the data is categorical, now remember from the last video, that means you can categorize people or things into, you know, people are left-handed or right-handed, people are male or female. T-shirts are red or orange or green or blue, right? You categorize information. A common way that we represent the data in terms of a table, not a graph, but a table, is called a frequency distribution. Sometimes you're going to see me flip my wording to relative frequency distribution, which means I'm going to take that frequency and divide it by the number of observations in the data set. I think this will make more sense when we go to the first problem. So I'm just going to jump straight over.
Yeah, let's clarify with an example.
Yeah.
So the first example is about motorcycle helmets, and I think I mentioned earlier that I have a gorgeous motorcycle, and I ride a lot. So you can read through all this, but there are different states have different laws about helmets, and some do not require them, some do. Arkansas does not, but you see this little sticker on the back here. This means this helmet is compliant. I am one of the compliant riders. So if you see me riding around, you'll see me with my very expensive helmet, okay? But I could have just a plain old bike helmet on, and that doesn't meet the standards of motorcycle helmets. So we gathered, or they surveyed 1,600 motorcycle users, and some of them had good helmets like me. Some had a helmet that was, kind of old school, but didn't really meet the standards. And some people just like the wind in their hair, okay? So of that total, we have the total. There were 733 riders who didn't wear a helmet, 153 who wore whatever they could get their hands on, a bucket or something, and 816 people like me who decided my brain's worth saving. Okay, so maybe not the rest of me, but my brain. So we can put that in a table instead of me writing down all their names. I can make a table out of it. So let's see what the table looks like.
Yeah, you see, really quick, you're not going to get a lot of consumers who want to read a paragraph if there's an easier way for us to display that information, right? So rather than a paragraph, we organize the information into what's called a frequency distribution. It looks like this.
And you could have, now, if you ever did this with, like, as you're counting something, often we'll do this with little tally marks. One, make little marks in a table and then tally them up as you're performing an experiment. If you did that in like middle school or whatever, you made a frequency table, okay? But once you have that frequency, the number of each of the categories, we can divide by the total number. I guess you had a different number in the previous page. Somehow you got
I didn't. You said a different number.
Oh, okay, I'm sorry. My bad. I must have read the wrong thing. See, because I didn't want to read that problem, but I can get the whole same thing right here on the table. Really.
That's right.
Number in each category by the total number of people we surveyed and get a percentage. And those percentages are proportions. Statisticians always use proportion, okay? Yeah. It's actually, it's not, they don't do a percentage. They don't multiply by the 100. They get a decimal. Okay, anyway, they get the proportion, and that proportion needs to add up to 1, or if we change it to percent, 100%. Okay, so we have to be able to account for all of the data, is what that says. Okay,
right.
And summarizes that whole paragraph that I didn't want to read in a little table. Okay.
Yeah.
Very quickly, I'm sorry, that we have, and I don't know where Ms. Young found this data, but in her data, about 43% of people were riding around without helmets. Trust me, I wave at all the other motorcycles. There are lots of them.
Yeah, I actually stole this data from a boring old textbook.
Oh, okay.
Nothing so exciting on this one.
Because of my motorcycle. I thank you for the shout out. And then if I don't want to look at it at a table, I can look at it as a graph. So we're looking at ways to represent a lot of information. And to me, this information is very important. So I thank you for picking this problem, Ms. Young, even if it was from a boring old textbook. I care about this personally. And if you ever want to ride a motorcycle, perhaps you do too, or perhaps you don't want to pay for all these people the insurance for all these people who are getting killed on motorcycles because they didn't wear a helmet. Anyway, this is a bar chart, which is a way of representing the data. So there's some key elements you need to know about a bar chart. First, that the bars are all the same width and that the frequencies the Y values are even and include the whole range so that I can compare the bars. If this bar chart started at 100 or whatever the number was, it would look even worse. And that's what happens a lot of time on TV stories and in newspapers. They mess with that frequency chart. I've seen some horrendous examples. We'll probably see some more later. Also with a bar chart, the bars need to be separated. They are not supposed to be butt up against each other to represent that these categories are separate and distinct.
Yeah, there are graphs that look like bar graphs where the bars are pushed together. Those are called histograms. So let's be clear here that a bar graph or a bar chart and a histogram are two totally different things. They don't even represent the same kind of data.
Yep. We'll talk about bar chart or histograms later, but that's coming. And then the final way to represent, another way, I guess this is the final way, is with a pie chart. And both of the bar chart and the pie chart allow you to compare categories, and that's their purpose. I can see the biggest category quickly, but I can compare relative sizes. And again, we use 100%, so we're finding a proportion of the circle.
Yeah, I think most people actually prefer, if you can get it into a circle graph or a pie chart, they actually prefer that because it's such a quick and easy way to look at information.
And I like pie.
And I like pie as well. I like coconut cream pie the best.
Blackberry is far better.
So we can also, so what we just looked at was if there was such a thing, a one-way frequency table, meaning we were really only looking at one thing. We were looking at the variable of helmet use, right? So that's rare that we're just looking at one thing and we're not making a comparison or anything like that. And so when we start comparing things, for example, if I wanted to know, if I had also written down as people were driving by, if it was a boy or a girl, or if they were, maybe actually I wanted to tell the difference between Harley riders and Indian. Is that what you ride?
Oh, I drive an Indian.
Indian motorcycles, right? Then that would add another variable to my data, because I'd be talking about motorcycle types and I'd be talking about helmet types or no helmet at all. What do you think, Mr. Bobby? Do you think that Indian riders wear helmets more often than Harley riders?
I don't know. I'd have to do some research, but both Harley and Indian riders I've met are all pretty stupid.
Oh, okay. So as soon as we introduce a second variable for comparison, we're no longer talking about univariate data. We're now talking about bivariate data. Bi meaning two, variate meaning variable, two variable. Pretty easy. And so now we're going to look at a two-way frequency table, which has more going on, but you can also maybe get some more information from it. So this time we're looking at a study where we asked a group of people what sport they preferred to watch on television, and then we broke them into two variables. The first one is male, female, and the second one is football, basketball, and baseball. And I also stole this one from a textbook. It's kind of a boring textbooky lesson, so I apologize for that. In a two-way frequency table, you want to add totals because that's how you're going to answer your questions. So you're going to want to add horizontally and add a total column.
40 and 22 and 15 do indeed make 77 and so on.
And add the columns and make a total row.
52. And they would horizontally and vertically, the bottom row and the far right column would both add up to 150.
Right. So just kind of looking at this, you know, I can tell you that there were 22 males in the survey who preferred basketball. Or I could tell you there were 12 females in the survey that preferred football. But, you know, that doesn't really tell me a lot because it's not taking into consideration the population, right? 12 isn't interesting if there were 400 people. I wouldn't expect a ton of females to prefer football. But 12 would be interesting if there were 15 people in this survey. So what I might do here is, oh, and I forgot to mention, when you are looking at your totals, your column total and your row total should be the same, and it should be how many people were in the survey.
I did that.
Oh, you did?
I did. Thanks for listening to me.
I'm sorry. My bad. Okay, so when we're looking at this data, before we turn it into relative, meaning I'm taking into consideration the population, a couple of vocabulary words, inside the actual numbers, before you look at totals, so you're ignoring all the totals, that's called joint frequency. And then along the totals, those are called marginal frequencies, right? So a marginal frequency would be 60 people total out of 150 preferred baseball.
Gotcha.
I'm glad you're interested.
I get it.
So marginal just means like in the margins, if you want to think about it that way. That's kind of the way I think about it, is in the margins. Okay, so now moving to a relative frequency table. So I took the exact same data, divided everything by the number of total people in the population. Now I'm saying that 27% of the people in the population, right?
were males who preferred football.
Yes, were
That-
males who preferred football.
and I can tell something about the population rather than just saying 40, because I don't know how many, 40 out of how many, unless I do some math. And you've done the math for me, so thank you.
You're welcome. Now, notice another thing here, that 35% plus 26% plus 40% should equal that total, but it doesn't. Why? Why, Mr. Bobby? Why?
You round it.
There's
You
some rounding error here. And guys, that is perfectly fine. It is perfectly fine if there's a little bit of round. Now, if you added up those decimals and you got like 7.6, that's
Yeah, like this adds up,
rounding error.
up to 1.01. And that's only because she went to 2 decimal places. She'd gone to 3 decimal places. Then, it would have been closer to 1, but it might have still been off in the 3rd decimal place.
Right.
And it always is because of the way you're going to round.
Right. Unless you just use fractions, but we don't do that. Not for this. Okay, so, and then also your column, your total column over here, we're going to add to 1.51, 0.49. That one actually works. No rounding error there.
And notice like for example, on the baseball column, 0.1 and 0.3 add up to 0.4. So the math works still even in relative frequency tables.
So if I asked you from this table, how many people in the survey preferred basketball, and I say people prefer basketball, where are you looking? Are you looking at joint? Or are you looking at marginal?
Marginal, and I would be able to answer that and say that about 40% prefer
Right.
basketball. That's the bottom of the basketball column.
Or if I asked you how many males were in this,
then I would go all the way over to the right under the total column for males, and it would be 51%.
that's a marginal frequency because it's in the marginals. It's in the margins, it's a total. But if I asked you how many females preferred basketball,
I would say 11%, and it would be in the, I guess, the female row in the basketball column. I don't know if you have that highlighted, but
I don't, but here.
Most mouses, yeah.
Yeah. Okay, one more thing about this. There's what's known as a conditional relative frequency. A conditional relative frequency. Look at my bottom totals. Look how I've turned all my bottom totals into 1. Conditional means it's conditional on whatever's happening, right? So, Ms. Robbie, how would you explain this?
That would be if I wanted to know what percentage of males liked football over female. So if I knew I was only caring about, for example, football, I'd go to the football column, and then I could break down the difference between males and female within that individual sport.
Right.
And same thing with the other sports.
Right. So this first column would be conditional on people who prefer football, right? And the second column would be conditional on people who prefer basketball.
Right.
So if we wanted to say what percentage of females let's see, how would we word this? Wonder if I have a question.
You go back for a second. Go back to that slide. For example, no, the one with the conditional. I can tell from the total that you were really close to evenly split. You had about half the males and half the females.
Right.
And then if I go to a football column, I can see that 77% of the people who liked football were male. So that's a male-dominated sport.
Right.
Likewise, if I go to baseball, I can see that in the baseball column, females prefer it to a higher percentage than the males. So that seems to be a female or favorite sport.
Right. So a question that you might see in on a practice might sound something like, given that the person prefers baseball, what was the proportion of females, or something along those lines? Or what proportion of females preferred baseball? Nope, that will go this way. Given that they prefer baseball. Anyway, yeah. Okay, so really quick, summarize really quick all the things that we've talked about so far. In terms of categorical variables, We report frequencies or relative frequencies using pie charts and bar graphs. Those are two types of graphs that we use for categorical variables. And then when you are looking at a two-way table, marginal would be a margin total out of the total population. Joint could potentially be, or joint will be a inside the frequency table out of total population, but conditional would be conditional on either a row or a column, right? All right, real quick, a practice problem. I keep moving us around. So we've got a group of students. This is totally fake data. And we asked them if they preferred math, English, or science. We broke them into gender. And the outcome you can see here in this two-way table. So the first question is how many students were in this survey? What do you think, Mr. Robbie?
That would be in the bottom right-hand corner, the number 315.
That would be in the bottom right-hand corner. You're right. Second question, how many females responded to this survey?
Then I would go across the girls row to the total, and I would see that number 150.
Yeah.
Not the 48, not the 0.48, but the total number. We're talking, she's asking me about numbers now, so I need the frequency, and that'd be 150.
Yeah. How many people preferred English?
So again, now I'm looking for a total. So I'm in the English column, and I can go down to the bottom and find the total number, or I could take the 40 and the 30 and add them, and either way I'm going to get 70.
How many males chose science?
So now I got to do an intersection of a row and a column. I can't do it, whatever. So I need to find the male row or the boys row and the science column and intersect those to find the 70 there.
So that was this 70. Males that prefer science, that's this guy right here. What percentage of students preferred math? What percentage of students preferred math?
Oh, wait, you should have made that the most popular one, 37%. I'm looking at because now she's not specifying any gender, so I would go for the total of 115 divided by 315, which is 0.37. And they may report that as 37% on it. That's what she did. Okay, she caught me.
It's what percentage? What is the relative frequency of
from decimal to percent, even in your head?
Yeah. What is the relative frequency of females choosing math?
Females that choose math. So I have females would be 150, and that was one that 50 chose math, so 50 out of 150. Am I right?
So maybe I worded it poorly.
Oh, the relative frequency. I'm sorry. Yeah. Females choose math. I thought you were trying to trick me to do the conditional one.
No, I wasn't.
Okay. No, you're right. It's 16. Sorry.
Yeah. Okay, so that's it on this one, guys. Some practice on Khan Academy for you. Look at my puppy, isn't he so cute? Okay, he's my grandpuppy, but whatever. So finish this up. There's not going to be a quiz just yet, so keep on keeping on. And I hope this video helped. You got anything else to add here, Mr. Bobby?
Sparkle on, dude.
Sparkle on.